Sample 2 for the hypothesis testing for the t-distribution, or one sample t-test. So we have a healthcare analyst, and we are told that this person hypothesizes that the average daily wage is less than, so that's a big keyword, less than 60 per day. It has a random sample of 8, so this one is kind of hard to find. That's going to be our n. And that sample has a sample mean here. So the symbol for that is going to be our x bar. That is 58.88. With a standard deviation, sample standard deviation, so that is 5.08. And we have an alpha of 0.10. So the only thing missing here is what the population mean is. So mu, well, let me actually put it here. Mu, it's going to be 60. We know that because that's usually what the claim is. They can tell you from past studies, from previous research, historically. So those are going to be the keywords to find the population mean. And it's usually when they're trying to test something, they're trying to test it for the mean. Could you do it for other, like the standard deviation or something like that? Yes, we just don't cover it in this class. So what would be our pair of hypotheses here? So remember, we always start with the null. It's always going to be mu here. Always is going to be about a parameter. In this case, the parameter is the population mean. So remember P and P. So parameter, and it's the population mean. Always the population mean, never the sample mean. The null hypothesis is always equal, and in this case, it's going to be equal to 60. It's exactly what we just wrote here. The alternative, it's also going to have a mu, and it's also going to be 60, but the symbol for the alternative is going to be different. And for that, we need to fish for in the text of the problem. So in this case, it's going to be less than. So less than, there you go. So the next thing we have to do is find the critical value. So the symbol that I use here is t-crit. So crit for critical. And the reason I like to distinguish between the t-crit and the test statistic is just because they're both labeled t. And it's just easier if they have something else to tell you what they are. So for this, we need the t-table. And we need the alpha, which is 0.10. We also need to know whether our test is going to be one tail or two tail, because we are using the less than symbol. So that tells you that it's a one tail test. So the next thing we need from here is going to be the degrees of freedom. So the formula for degrees of freedom is n minus 1. So our n is 8 minus 1, so that's going to be 7. So that's all that we need for finding the critical value, t-crit. So from here we can go to the table. So here I am in the t-table. I'm looking at one tail because it's a one tail test. I'm looking for my alpha over here in this row. It's 0.10. My degrees of freedom was 7, so it's going to be this value here. So my t-crit was 1.415. But remember, we're doing a one-sided test and is less than. Oops. So that means we're looking at the left tail. So that tells me that this is going to be a negative value. I need to put the negative in there. That's all I have to do in this section. So the next thing I have to do is find the test statistic or test value. That's another name for it. I like to also call it t-obtain. So this is what we obtain from the sample, whether this as the t-critical we get it from the table. So the table one is a theoretical value, and the one we're going to get, because it's obtained, and we obtain it from the values we got from our sample, it's an empirical value. This is going to be our formula. So x bar minus mu s divided by the square root of n. So we had those values. It was 58.88 minus 60. That was our population mean. this is going to be 5.08 divided by square root of 8. So this in the top here is going to be 1.12, and then in the denominator, when I do this part, I get 1.80. And it's going to be negative 0.62. This is going to be my test statistic. So there's two ways of making the decision whether we reject or not. The first one is using the critical value and the test statistic. So my t-crit was negative 1.415. So this was my rejection region. My test statistic, or t-obtain, I forgot to label it here, t-obtain. My t-obtain would be very close to the mean, close to 0. So t-obtain is going to be negative 0.62. And it's not in the rejection region because it's not in the shaded area. So when the t-obtain is less than the t-crit, we do not reject the null hypothesis. So the second way of deciding whether we reject or not, it would be using technology. So it would be calculating what we just did using either a calculator or using Jamovi. So here I have the table for Jamovi, and I have it here to help you interpret for your data projects. So I have the p-value here. I also have the degrees of freedom, and I have the test statistic that I just calculated. But for now, because I'm trying to make a decision, I'm going to focus on the p-value. So what we do with the p-value, 0.276, is that we compare it to our alpha. So for this problem, our alpha was 0.10. And we can tell that the p-value is actually greater than our alpha. Whenever the p-value is greater than our alpha, we do not reject. So the conclusion with using the critical value and using the p-value should be the same. The only time where you will find a discrepancy is if I made a mistake, and I've made it before, so it's okay, don't worry. And I try not to do them often, but they should align. So whichever method you're using, you should get the same conclusion. If you are using software, and if you do have to do stats in the future, you will use software. You will most likely use. So now let's go over our conclusion. We need the name of the test, which I have here. Another name for this test would be hypothesis testing for t-distribution. The next thing we need is the significance level, which we have over here, and we usually get it from the text of the problem. Our next step would be to say whether we reject or not. So we decided to not reject based on both the p-value and the critical value. Remember, when our p-value, we decide to not reject the null hypothesis, that means there's no statistical significance. Reject. If we had rejected, that means we would have had statistical significance. So in this case, there was no statistical significance. It's also asking about the magnitude. In this case, because our p-value is larger, let me show you, is larger than the alpha, we just say there's no statistical significance. This table is in your notes, and it comes from this textbook. The next thing would be to have a little sentence on the problem. So in this case, we have evidence that the daily wage was less. There was no evidence that the daily wage was less than 60. So this piece is essentially then the alternative hypothesis, mu less than 60. And then finally, we have the little APA style notation. What do we have here? We have the little t that tells us that we use a t-distribution. We have the degrees of freedom. We have the test statistic, and then we have the p-value.